Okay, this will be a little video about my fan setup here and how I perform it. This is a 90 millimeter Schubeler fan. It is a DS51 AXI HDS. As I said, I think I said it's a 90 millimeter. Anyway, it's a 90. Coupled to it, I have a ARC 3675 1.5 1130 kV brushless end runner. Pretty nice motors, a little low on the amp drop compared to like an HET. Hopefully I'll stay in the air a little bit longer. 5 millimeter shaft. Pretty nice motor. This will be my second build with one of these. I just like to show you how I do it. I do things a little bit over the top in a way that I choose to grind flats on the 5 millimeter motor shaft there for the set screws that are actually on the rotor. Schubeler has spaced these 120 degrees apart, so rather than use a Dremel tool and guess at the 120 degree increment and, as well as the depth of the flat, I've built myself a little indexing fixture, and I'll mount the motor in a Bridgeport, and I will grind at 120 degree intervals to the depth they specify, which is half a millimeter, which works out in to be 19 thousandths and 6/10, so it's not very deep on the shaft, but I prefer to get them all just where they're supposed to be to mate perfectly with the 3 set screws on the rotor. This assures that the set screws are all a common height once they bite down on the rotor shaft or the motor shaft, and hopefully, you know, the theory here is get the set screws all the same height, and we maintain the balance of the rotor. Schubeler did pre-balance. I checked it, which was a waste of time. You can actually see where they've removed some material to achieve some balance, and one of these holes here, they've actually added some sort of epoxy or potting compound. But it needed to be a little bit heavier right there, so that's how they chose to do it. As I said, it was a waste of my time really to check this, but I did it anyway, and you should too. I wouldn't really trust anybody, but well, I suppose I could have trusted Schubeler with this one. But this setup is going to run on a 12 cell, so we are going to see a significant amount of RPM here, approximately 45,000, and this out of balance at 45,000 will, well, of course, cause its premature failure. Could take out the bearings in the motor. And let's face it, this thing comes apart at 45,000 RPM, it is going to shred your airplane for you. So you don't want that to happen. Anyway, what I've done here is I just mocked this up. My centering ring here, if that's what it's actually called, it's just in place here. It's not epoxied in like it's supposed to be. Anyway, what I've done here, I've put my motor wires down at the 6 o'clock position. This is just where I prefer to have them. They tuck around down nice through the thrust tube for an easier hookup to my ESC. I start by doing this in the 6 o'clock position because it will make more sense. It'll be, well, not that it makes more sense, but it will help us when we get this thing up in the Bridgeport to orient where that first flat is. And why this is so important is Schubeler has put a hole in the shroud. There's another one down here in the inner portion here. It's a notch here. A Allen wrench will protrude, will just insert through here, right down, and it will allow you to get the set screws that are on the rotor. What I do is I time where the flats are to the motor case to assure that the cog of the motor puts a flat directly in line with that hole. It makes assembly a lot easier. So that's pretty much why that is done. I'll walk you through some other stuff too, some of the products I use, the Loctite for the set screws and all the assembly. Loctite epoxy to hold the centering ring to the OD of the motor, as well as the 3M Alumitate, 425 actually, to build up the OD of the motor so it is touching the inside of this hub here, which is important to pull away heat off the motor, as well as a heat sink to go on the back. Anyway, I want thermal compound to aid in the heat transfer. Anyway, so that's how this is going to go. This is just kind of like a kickoff here. We'll get it up on the mill here shortly. Of course, the motor will not be in the fan housing here, the shroud. That has to be removed. But yeah, that's how that all goes. So anyway, stay tuned, and we'll get this thing going. Hopefully everything goes well. We'll get it up on the stand after it's all done, and we'll do some tests. I'll show you some amp draws, as well as some RPMs, and you'll also get to hear it, which is pretty impressive, I might add. It do make a lot of noise, not turbine noise, but it's they're loud. They sound good. Anyway, that's that. If I can get this thing off of here, we'll have something. Okay, there we go. All right, stay tuned.